Hello everyone, in this simulation we're going to investigate the flux density effect on the size of the force and wire in a magnetic field. Here you can see a piece of mild steel bent into a U shape onto which magnets can be fixed. A conducting wire is passing through the middle of the U-shaped steel. Let's drag the flux density slider one notch to the right negative side. You can see that 2 blocks of magnet have been added to the steel. A magnetic field increases the flux density B from its initial 0 value. Now let's select field lines to show some of the lines of the force of the magnetic field that pass from the red north face of one magnet to the blue south face of the other magnets. Now let's reverse the field, moving the flux density slider one notch to the left from the central 0 position. So we're going to reverse the density direction. Now let's make it stronger by moving it to the left one notch. What happens? Well, the magnet increases in size and more force lines appear. Let's select Field Lines and Vector to show a single horizontal black arrow. This vector represents the flux density value and its effect on the yellow wire. Now let's drag the flux density slider backwards one notch towards the 0 value. What happens? Well, the magnet and the vector arrow decrease in size, indicating a weaker magnetic field.